Welcome back. Let's finish off this week by compiling this information we've created, the skeleton and the skin weight information, down into a digital asset that we can use throughout our process in creating our rig for this character, and that we can hand off to other people in our pipeline if maybe they want to create their own custom rigging setups, but everyone wants to use the same skeleton and same skin weight data without needing to reproduce it all. We're going to do so just by using a ROP export, a ROP geometry output. We're going to do one for the rest skeleton that we've already made way up here at the beginning of this week, the beginning of this video, this week's video session. ROP geometry is going to be our rest skeleton, and I'm going to go ahead and save this as our cyborg rest skeleton, and we can just save that to disk. Perfect. And I'm going to come down here and do the same for our mesh data. We don't want to grab our bone deform data, since after this point it's just regular mesh. We can see that our transforms and other aspects of this can affect this mesh. You can at any point, but there's no possibility of using rig pose data because we don't have skeletons, and we can't do capture layer paint. We can't see that information because after the point of our bone deform, it just becomes a regular deforming mesh, and all of our attributes that we need are compressed down, and we don't get to edit them anymore. So we're going to grab our mesh data before we put it into our bone deform right here, and we're going to just save that as our cyborg skinned mesh. That seems like a good name. And we'll save that to disk as well. Now we are going to just create a new subnet. I've noticed that in this version of Houdini, sometimes just trying to create a digital asset by doing asset new digital asset from selection sometimes doesn't work so well. So we can do a workaround by creating a new subnet, and we can just create a digital asset from here as such, and we're going to call it something along the lines of cyborg skinned rig, maybe. That seems good, and we can save it. Minimum inputs, we don't need any inputs for our skinned rig, but we will need 3 outputs. We'll need that skinned mesh that we have, we'll need our rest skeleton, and then we'll want to also provide a path for a deformed skeleton. Not that we will edit a deformed skeleton chain inside this asset, but we will have 3 outputs to match perfectly with our 3 inputs of our bone deform. And we can come in here and name them as well. So we can have deform mesh, rest skeleton, and deform skeleton. And we can hit apply and accept for now. And we can see that our subnet, when we dive into it, we see it's named cyborg skinned rig, and if we delete the subnet name, we get that default name that it was given. When we dive in, we see that we only have 1 output, and we will want to embed this HDA with our assets that we just had. Right now, our assets are existent in a file that we can't really pass on to someone else, we have it in this file that we just saved out, our cyborg rest skeleton and our cyborg skinned mesh. But right now, we see that we're doing a file reference to hip geo. But if we were to just give this singular HDA file to someone, we don't want them to have to make sure that reference data is in place. We just want to give them this HDA, allow them to put it into their OTL library, or to sync it with maybe your server's OTL/HDA library, and for anyone to be able to pull it out and have the meshes set up without needing special referencing. The way we do that is we can go into our type properties for our HDA. In extra files, we're going to add our skeleton and our mesh data. It's important to note at this point, any changes that are made or requested on these files from our exports will need to be re-imported into the extra files section of our HDA. Our HDA doesn't automatically update the files when we replace them in our folders, since we're kind of embedding them into this HDA. The way we are going to do that is we're going to just look up where our files are. We're going to choose them. We can do so from the $hip and just grab our skeleton and our skinned mesh. We can hit accept, and we'll hit add files. We can see that there's now a little asterisk or a star next to these two geometries. It means that they're inside of our HDA, but they're not saved there yet. Once we hit apply or accept, we can see that that asterisk has gone away, and we can see that they're now inside of our HDA permanently. Anytime we create a new HDA, if we create a cyborg skinned rig and we check its type properties, we can see that it has those files there, just like the last one. So how do we reference those files inside the HDA now? Well, we'll just start with grabbing a simple file node, and instead of referencing our $hip geo, we're going to go into our opdef library, and we'll want to know that we were creating a SOP level HDA. So we'll dive into our SOPs, and in this list of SOPs, we should now be able to find all of our custom-made HDAs. We can see a bunch of cyborg HDAs that I've created throughout this course, but ours was the skinned mesh, our skinned skeleton. Or my bad, it was actually named Owen because I didn't rename that aspect of things. Owen cyborg skinned rig. Here it is, and if we dive inside of it, we can see that our BGOs for our skeleton and our mesh are there. So we can grab our skeleton, and we can call this rest skeleton. And we'll want to also grab our skinned mesh. If we put our display flag on the skinned mesh, we can see our materials are currently applied because we exported our pathing. But if we were to skip over this material, or even if we were to delete this material path and not have it, then we don't have that reference anymore. So I'm just going to move these two nodes inside of our HDA so that whenever someone creates it in the future, they now get that material applied. We need to update our references here, and the way I'm going to do so is instead of having a tied down reference as such. I'm just going to use relative references with our periods. So if we go period, /, we're grabbing this layer of things, and then we're grabbing our net1 and then our black. And I'm just going to go through and do so for the rest of these materials. Perfect. So there's our skinned mesh, which is our first output. And we'll need a new output for each of our rest skeleton and our deform skeleton. And we'll want to make sure we change the output index. And we can name this rest scale out and our deform scale out. And we just put our skeleton into both of those, and now when we pop back up, we can see we have exactly 3 outputs that will match our 3 outputs of a deform of a bone deform perfectly. You can also, of course, change the colors of your outputs if you like to see a different color for your outputs, and it'll update here. I like to do blue, gray, and orange, and we can even start to edit straight in this section of things, and we'll see that our mesh, exactly how we exported it, is here. Perfect. So as we can see, we no longer have that tied down, or we don't have as much need for all of these nodes when we're handing things off to one another in any pipelines. We don't need to deal with having this amount of information. All we need are a few simple nodes packaged into an HDA, and we can start to pass this one HDA around. You want to make sure that you either do a save node type, or sometimes that save node type doesn't quite work. You can come into type properties and hit apply and accept, and that'll definitely save over your node. And now whenever we create a cyborg skinned rig, we can see that everything is updated. Our meshes are referencing materials properly, and we can put that into a bone deform just like we did right here and pass it along to anyone in our company, or we can just use it from here on out instead of all of this data. So that's what we'll do from here on out. We will use this as our base for creating rigs off of. Alright. Thank you for watching this week, and I hope everything goes well with your skinning and rigging of your skeleton.